Hello students, in this video we continue the topic correlation, and in previous video we have seen the concept of fundamental concept of correlation, and now in this video we take some examples. We are going to see some examples on the concept of correlation. Okay, so we start now. We take in this video there are three examples. uh, Example first and second will be based on the concept of correlation on the two variables, that means the for bivariate populations, and in third we see a different type of problem on the concept of correlation. Okay, so we start now. So example one, what's this examples ask? This example, this question says that the table below gives the marks of 8 students in a test in two subjects A and B. Uh, you see the table here in this question, and there are 8 students and two subjects A and B. So what are the marks in front of your eyes here? So the first student has the marks 10 in the subject A and 9 in the subject B, and similarly the second, third, fourth, fifth, sixth, eighth, sixth, seventh and eighth students have different marks. So the question asked here, calculate the coefficient of correlation between the marks obtained by students in these two subjects. So what we see here, we are asked to find the coefficient of correlation. When we were discussing the concept of correlation, then we discussed the definition of correlation, and in that time we have discussed the definition. So what is the correlation, and you see now the what is correlation in the example. Okay, so what is the coefficient of correlation we have to find here. So we use the fundamental formula for this coefficient of correlation. Here we see, here you see that's the coefficient of correlations formula. That's the summation of capital XY by the square root of summation of x square capital and into summation of y square. So by the use of this we have to obtain. So what we need to find is the capital X and capital Y, and the capital X square and capital Y square. Okay, so according to our requirement we are going to draw the tables here. Okay, so what we see here, capital X is the X minus X bar, and capital Y is Y minus Y bar. What is the X and Y? X the marks in subject A, and small y is the marks in the subject B. Okay, so by the use of these given table we find this table, new one table, and then we find the product of xy, x square, y square capital. Okay, and then finally we check its final value, okay, in last. And we see here what's the mean. So mean of x series is 80 by 8 is equal to 10. What's the 80? 80 is the total summation of a small x. What's the y bar? Y bar is equal to 64 by 8. What's the 64? 64 is the summation of total number of small y's. Okay, so by which we find the x bar and y bar, and then we subtract these from x, then we get the capital X, x minus x bar, and similarly y capital, that is y minus y bar, and then xy capital, x square, y square capital. Okay, then we find the total values, and then we substitute those values in this, and then we find its values finally 0.896. Okay, so that's the coefficient of correlation for the question number 1. Okay, so now we move to the second question. Second is also the similar one. The ages of husbands and their wives are given below in the table. So you have the age of husbands and the age of wives. So there are 5 entries. Okay, so n is equal to 5 here. Okay, so what you see here, the correlation between the age of husband to the age of wife. Okay, so the age of husband is 23, then the wife's age is 18. When husband's age is 27, then the wife's age is 22, and so on. Okay, so find the coefficient of correlation between x and y, that means the husband's age and wife's age. Okay, so similarly we draw the table again. What we do here differently than the first question solution, that we take x and y same same to the previous solution, but what we do here, the different thing is small dx in place of capital X. Here we take dx. Okay, and in place of capital Y, here we take dy. Okay, so what's the dx and what's the dy? So dx is the x minus x bar by a particular number, and that particular number may be anything, but if there is not a particular number, then we divide it just by 1. Okay, and similarly for dy, that is y minus y bar by a particular number. Okay, so what is in this question, what we see here is x bar is equal to x bar. You see here x bar is just 28, and we subtract the 28 from all of the x. Okay, so 23 minus 28, that's a minus 5. 27 minus 28, that's a minus 1. 28 minus 28, that's a 0. 29 minus 28, that means 1. 30 minus 28, 2. So we divide it here by just 1 1 1. And if suppose if there will be 230, okay, 270, 280, that is the multiple of 10, then we divide all the entries by 10. Okay, and so on. So that's why we find dx small and dy small, and similarly we find the dx square, dy square, and the multiplication of dx dy. Okay, and then in previous video we have seen that the value of the coefficient of correlation can be obtained by the small r, that's this, and here we have the table, and from all the values of the table we are going to substitute the values in this formula, and then we find the value of small r. Particularly for this question, small r is 1. So hence the ages of the husband and the wife are perfectly correlated, because the correlation coefficient of correlation is 1 exactly here. Okay, now we see the very different question here. That's the problem number 3. Okay, so what this question asks: following table gives a bivariate distribution showing frequency of marks according to A's by a group of 100 students in an intelligence test. So what you see here uh, in this table, there are a first column that represents the marks. So that means that's are actually class interval of marks. So 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, and the last is 60 to 70. And what's the another thing here mentioned, that's the age. So age in years, so that's are the 18 years, 19 years, 20 years, 21 years. Okay, So that means there are four persons uh, of the age 18 years, which marks lie between 10, 10 to 20. There are two persons of the age 19 years, which marks fall in between 10 to 20, and similarly. So what we see here, there are two things. One is age, another thing is marks. So that's why this is the bivariate distribution here. And what we see here, two types of total values. That means we have the two columns for totaling. Okay, one we see here vertical, okay, and one we see here horizontal. Okay, so by this you can also identify whether the given question is, whether the given distribution is bivariate distribution or not. Okay, once we understand this, then we use the answer of this type of question particularly in this way. What we do in this way, we do actually the first of all we draw the uh, class interval of marks. First of all, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70. Okay, and then we write just above it, that's u, and there is v. So what is the u? We have mentioned here u is equal to x minus 19. Why? Because what's the what's the values of x and y? We have to see here. uh, what we see here, that we divide one particular column, that box, in x and y. What is, so what is the values of x here? For one variable we represent x, and for another we represent y. Okay, so what is the x here? The values of x here: 18, 19, 20, 21. And what's the values of y here? 15, 25, 35, 45, 55, 65. Okay, so I suppose here just 19 I have to subtract from each of the x. Okay, you may take it for 20 also, 21 also, 18 also, or any number. Okay, so x minus 19 we represent u, and similarly y minus 35, that means for v. Okay, so now what we see here, particularly when you subtract 19 from all of the values of x, then we see here the values are minus 1, 0, 1, 2. But when we subtract 35 from all of the y, that means for example 15 minus 35, then we see that the remaining is minus 20. When we see the subtraction of 25 minus 35, then we see there is minus 10. So that was all are the multiples of 10. Then so that's why we divide it by 10 also. So v is equal to y minus 35 by 10. Okay, so by which we draw this table. Similarly, we proceed this, and there you seeing here, that's are the boxes, small boxes in this table. That's are in first row there are 8, 0, minus 4, then after 5, 0, minus 6, minus 8, 0, 0, 0, 0. How these numbers arrive here? So these numbers comes after, when we see here just 8. How this 8 comes? So this 8 comes by the multiplication of this 4 just below it, and the multiplication of minus 2 in the left of, 4 there is 10 to 20, in the left of 10 to 20 there is 15, and in the left of 15, there is minus 2. So that's minus 2 is multiplied to 4, and that is multiplied to minus 1. So what we get is minus 2 into 4 into minus 1, that is 8. Okay. Similarly, we get minus 2 into 2 into 0, that is 0. So we write 0 in the box. There is a description here. Here you see 8 is a multiplication of minus 2 minus 1, and 4 0 is the multiplication of minus 2 0 and 2. Similarly, okay, that's why we write the values here. Okay, and that's the values of that's the values represented in this box. And after then we write here as the total is represented by the f, then after f into v, then after f into v squared, then after f into u into v. So what's the f into v here? So first value of f into v here is 8 into the value of v, that is minus 2. So 8 into minus 2 is minus 16. And then after fv squared, that means the f is 8 and v square is minus 2 to the power 2, that means the 32. And then there is a very important thing, that is fuv. What you have to, how you can find the value of fuv here, that is 4. You are seeing fuv, the first value of fuv, that is the value of the addition, the total summation of the number in these boxes. Okay, so 8 plus 0 minus 4, so that is 4. Okay, similarly for the another boxes, there's another row, that is 5 plus 0 minus 6 minus 8, that is minus 9. Okay, and so on. So you may find the values of f into u into v in this way. Okay, similarly we can find the values of fu, fu square, fuv. Okay, finally by the addition of total fuv and total fuv horizontally and vertically, both are same, that's a 52. Okay, now we substitute these values from this table here. Here in this the main formula of the coefficient of correlation, that's the r is equal to n into summation f dx dy minus summation f dx summation f dy, denominator this. So then we substitute the particular values from here. Okay, so what is the values of dx and dy? So we already mentioned it here, that's the u is nothing but the dx and v is nothing but the dy. Okay, so we substitute all the values and then we find the value of the coefficient of correlation r here, that is 0.25. Okay, so that's are the examples on the concept of problems on correlation. Okay, in next video we will see some more concepts. Okay.